Unit 2, Classification of Matter. Make sure at the end of the tutorial you're able to answer these 4 questions. Alright, we're going to classify matter, and we can classify matter into 2 big categories, pure substances and mixtures. With substances, we're going to be able to write the chemical formula, and we can break it further down into elements and compounds. Elements are one type of atom. They're found on the periodic table. If it's not on the periodic table, then it's not an element. So here we have gold, and if you look at a molecular picture of gold, you'll see that each one of these elements, each one of these atoms is exactly the same, and it's the same throughout. So that's an element. Here with a compound, you have 2 or more different atoms chemically bonded in a fixed ratio. So if I have water here, water is always 2 hydrogens for every 1 oxygen, H2O. If I were to change that and put a 2 here and have 2 oxygens, now I have hydrogen peroxide, a completely different compound. So you can't mess with these subscripts here or you change your compound. The compound is in a fixed ratio. It doesn't change. So here if you look, you've got, this is salt, sodium chloride. For every 1 sodium, you have 1 chlorine. And if you're to look at a molecular drawing, you have 1 chlorine atom, 1 sodium atom, 1 chlorine atom, 1 sodium atom. So you have that fixed ratio over and over and over again. These don't change. With mixtures, however, they do change. Their ratios are variable. And we can break mixtures up into homogeneous solutions and heterogeneous mixtures. Solutions can be solids, liquids, or gases, so that don't think of them as just liquids. Here we have a piece of bronze, and bronze is copper and tin mixed together. It's an alloy. And if you look at bronze on a molecular level, you'll see atoms of copper, atoms of tin. Here, an atom of copper, we got 4 of them, and then over here 3 tins. So we have 2 elements together and they're combined, but they're not in a fixed pattern. They're just well mixed. So think of homogeneous solutions as just well mixed. Heterogeneous solutions, they're going to tend to be chunky and have great big chunks. Things like colloids. Colloid you can't shine a light through, like mayonnaise. Mayonnaise has little tiny bits of fat in there that you could pick out. And suspension. Suspension is something that will separate. So if you've ever had to take medicine, it says shake well before using, that's a suspension. Your liquids have separated out into 2 distinct layers and you need to shake that up. States of matter. We have 3 states of matter, solid, liquid, and gas. And if you look at a solid here, you see these atoms are super close together. We're not going to be able to get these atoms any closer than they already are. So solids are not compressible. They also have a fixed shape. If you were to drop a solid onto like a hunk of sugar into a glass, it's not going to take the shape of the glass. It has a fixed shape and a fixed volume. With the liquid, we've got space here in between these molecules, so we can compress a liquid. It's compressible. It will also take the shape of the container, so no fixed shape. If you were, whatever container you would fill water with, it's going to take that shape of the container. It does, however, have a fixed volume. If you were to pour water into a glass, it wouldn't expand and take the whole volume of the glass up. It's going to stay at that fixed volume and settle at the bottom. With a gas, we have a ton of space in between molecules, so a gas is very compressible. And it will also take the shape of whatever container you put it in. And a gas will take the volume of the container that you put it in. It will expand to fill the whole space that you've given it. So no fixed volume. Alright, this is a phase diagram. Every compound element has a phase diagram, and it tells you at a certain pressure and temperature what phase you'll be in, a solid, liquid, or gas. So here we've got pressure on the y-axis and temperature on the x-axis. And if the compound is found in this region, it's a solid. If it's found in this region, it's a liquid. And if it's found in this region, it's a gas. This right here where the three lines intersect is called a triple point. At that particular pressure and temperature, you will see all three phases coexist. This here is the critical point, at which point a liquid will turn into a gas. No matter what you do, increase the pressure, increase the temperature, it's going to become a gas. Phase diagrams also indicate phase changes. So if I'm going from a solid to a liquid, I'm melting. And here, as soon as I cross that line, that's my melting point. Now if I'm going from a liquid to a solid, I'm freezing. And as I cross that line, that's my freezing point. Okay? If I'm going from a liquid to a gas, I'm evaporating or boiling. And here, as I cross that line, that's my boiling point. If I'm going from a gas to a liquid, that's called condensation. If I'm going from a solid to a gas, that's called sublimation. And if I'm going from a gas to a liquid, that's called deposition. All right, here's another type of phase diagram. This one, though, is temperature on the y-axis and energy or heat on the x-axis. Each one of these represents a phase change. So here, we're going to start out with a solid. And then the flat part is the liquid. And then the other flat part up here is the gas. And as you increase your temperature and add energy, this is where your phase changes happen. That's where your phase changes happen. So if you're going from a solid to a liquid, this is when you're melting, you're adding energy. You're going from a liquid to a gas, you're evaporating. You're adding energy. Okay. All right, physical properties. Physical properties can be observed without changing the composition of the matter. This is anything you can observe with your five senses. So the look of it, the shape, the color, size, how it smells. And if you smell something, you want to waft. You don't want to stick your nose in it and take a big deep breath. You want to kind of gently waft it towards your nose. And then texture. These are all physical properties. A chemical property can only be observed by changing the composition of the matter, its ability to react. So if it's flammable, if it will react with oxygen or oxidize, anything to do with how it will react, reactivity. These are all chemical properties. Physical properties can be classified as either intensive or extensive. An intensive property does not depend on the amount of matter that is present. So it doesn't matter how much of something I have, its color will be the same. It doesn't matter how much of something I have, its texture will be the same. Its density will be the same. Its melting point will still be the same. It doesn't matter how much of it I have. So melting point, boiling point, the phase of matter that it's in, if it's a solid, liquid, gas, that doesn't depend on how much I have. An extensive property does depend on the amount of matter I have present. So it's mass, it's volume, things like this, length. All these things matter how much I have. Physical properties can be used to separate mixture. Here are a couple common separation techniques. This is filtration. So you're just pouring your liquid. You have a liquid, a mixture of a liquid and a solid. Pour that through the filter paper. The filter paper catches your solid and you have your liquid come out the bottom. So that's a way to separate a mixture based on phase changes. States of matter, or the phase. That's a physical property. Here we're using boiling point. So if we have salt water, salt is going to evaporate at a much higher heat than water. So if we add water here, if we add heat here, the water will evaporate and then filter down here, and you're running cold water through here. So this is the cold part. So we cool it back off and collect the water here, and your salt will stay behind. So we're separating a mixture based on boiling points. Density, the amount of matter in a given space. So here I've got 3 equal volumes. Which one of these would have the highest density? It's the amount of matter in a given space. So if our volumes are equal, this has the highest density because there's more stuff in it in the same given area. So if you look at a density column, here honey is on the bottom. It's sunk down to the bottom. So honey has more stuff in it than, say, lamp oil. Okay, so here water is less dense than Dawn dish soap, but more dense than vegetable oil. So the most dense material will be found at the bottom of the column, and the least dense will be found at the top of the column. Alright, this is the equation for density. Density is mass divided by volume. So let's go through some examples. We want to calculate the density of a material that has a mass of 52.457 grams and a volume of 13.5 centimeters cubed. So I know my density equation is density is mass over volume, and a cute way to remember this is that you love density. See, mass over volume. So my mass is 52.457 grams divided by my volume, 13.5 centimeters cubed, and I just divide. And when I get my calculator, it comes out to 3.8857, but I need to round. I'm multiplying, so I have to look at least number of significant figures, which is 3. So I need to round this to 3.89 grams per centimeter cubed. Okay, some more practice. A student finds a rock on the way to school. In the lab, he determines that the volume of the rock is 22.7 milliliters and the mass is 39.943 grams. What is the density? Okay, so my density equation is mass divided by volume. So I'm just going to set this up. 39.943 grams over 22.7 milliliters. Just going to divide, and when I do, I get 1.7596. And I need 3 significant figures because I'm looking at least number of significant figures, so 1.76 grams per milliliter. Can't forget my units. The density of silver is 10.49 grams per centimeter cubed. If a sample of pure silver has a volume of 12.993 centimeters cubed, what is the mass? Okay, so now I'm trying to find mass. So I'm still going to use my same density equation. I know my density is 10.49. I don't know my mass, but I know my volume is 12.993. So I need to find, I'm looking for mass, so I have to multiply these two together. So when I multiply, I get 136.296. And I'm multiplying, so I'm looking at least number of significant figures, which would be 4. So I need to round this to 136.3 grams is my units. Here, last one. A 24.8 gram marble is dropped into a graduated cylinder containing 10.5 milliliters of water. After the marble is submerged, the water level rises to 12.3 milliliters. What is the density of the marble? So since we can't actually measure a marble, we use what we call water displacement. And since I know that my water level rose, I can just subtract these two values and get the volume of my marble. So 12.3 minus 10.5 gives me 1.8 milliliters. So that's my volume. And I need one decimal place since I'm subtracting, which I have, so I'm okay there. And then I'm going to plug it into my density equation. I don't know my density. I know my mass is 24.8 grams, and I know my volume is 1.8. So I divide those, and I get 13.7777. Okay. Since I divided, I need to look at least number of significant figures, which is here 1.8. So I need to round this to two significant figures, which is 14 grams per milliliter. Right, physical changes. Physical changes are concerned with energy and states of matter. Physical changes do not result in a new substance. So a physical change would be like if you tore a piece of paper in half, tearing, breaking glass. Just because you break it, it's still glass. Dissolving. Even if I dissolve sugar in water, I can evaporate the water and I still have my sugar. So I didn't change the sugar at all. I just mixed it really, 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 really good. So tearing, breaking, dissolving, melting, evaporation, any type of phase change is going to be a physical change. Now, chemical changes happen on a molecular level, so we are going to change our new substance. So if we set something on fire, combustion, you're changing it. You burn a piece of wood in your fireplace, afterwards you have ash, you have carbon, you no longer have wood. Digestion. After you eat an apple and it comes out of your body, are you going to want to eat that again? No, because it is not an apple anymore. Oxidation. This is when substances react with oxygen. So if iron reacts with oxygen, you get rust. What else? Anything that's going to change your substance is going to be a chemical change. So you just have to ask yourself, did I change something? All right, if you can't answer the questions at the beginning of this presentation, then you need to watch it again.